Hi, today I'm going to show you how to utilize the Sprkl dashboard to get a better understanding of testing execution with the Sprkl CLI. I've launched a microservices example repository with Jest testing and launched it with the Sprkl CLI to get more information of how to run Sprkl. Go to the getting started page in our documentation. So I've already launched the services and made a testing suite for that, and we'll see what the dashboard can tell us about the code changes that we've made. So let's go through each section in the dashboard and overview what it's offering. So the first section will be the errors. As you can see, the errors also have a little toggle button which switches between personal view and global view. Also the interactions and the security have the same toggle, and it behaves the same in these three sections. So if I click on the personal versus global view in the errors, I can see errors related to code changes on the global view, but also to APIs. And if I toggle back to personal view, I'll see only code changes. So the personal view will focus more on the code changes in compared to the global mode, which also gives the personal overview, but also a more global view of the errors. So each error is either an exception which was thrown through a code change that we've made, or an API that has an error on it, or a database call that has an error on it, will result in errors on the dashboard. So we'll get the error message here and also a code reference where that error went through. So we can click on the sloth icon and see that it went through my HTTP request here, which is logical since this is an HTTP request error. And we can open up also the trace to see how it happened and what caused it. So we can see here the HTTP put request, and we can see that it originates from some error with a code change that we've made. So we can click on the slot icon here and see that it originates from this section, and it's probably related to all the other errors here on the error section. So these are the errors. The coverage section is the next one. We've split the coverage into two areas, the covered and uncovered. Also note that the percentage that you see here is not code lines coverage, it's actual code changes coverage, which means that we count how many code blocks that were marked by Sprkl were actually executed. So this is our way of showing coverage, and this way you can determine if, for example, your testing is having enough coverage for your changes instead of the whole system. It gives you a personal overview about the code changes. So I can see that we've got to all these code blocks. All of these were executed. We can see the trace for each of them in the covered section. And we can also see the uncovered one, which has no trace related to it. Since we haven't found any trace, it's not executed, and we say it's uncovered. So this if was not passed, and we went straight to the else, which was covered. So this just tells us that maybe my testing is not covering everything that it needs to be covering, and maybe that's okay, it's not covering all of it, but this is a very fast way of understanding what was covered and what was not in your code changes. The next section is insights. Insights are some interesting conclusions that we've made when we looked at the tracing. So an example insight is a circular call, that metrics called get to metrics, which means that the circular call means that the service called itself through the API instead of calling an internal function. Maybe it's okay that it called itself through the API, but maybe it's not. It's just an insight which can tell you a lot about your recent changes. So maybe when I'm running my test, maybe I'll see, okay, I need to handle that. Also, another cool insight is the async work added in the API. So this will tell me that the API was, the request time was not harmed so much, but another work was added after the API is finished. So this is what it meant by async work was added. So if we'll see, this is regarding the posts to the order service at /orders. So I think it's this one. Yeah, it looks like this one. Yeah. No, this is the post request to payments, and this is the post request to orders. Yeah. So I can see the API operates in 70 milliseconds, but there is a ripple effect that causes another work to be done even after the API has finished. So these are two example insights that can be very useful and can help you code with more quality. The next section is the insights. The insights are network interactions or library interactions that are interesting. So for example, we have here the HTTP REST API interaction. You can see that we have a GET request to the metrics/metrics API from this code block. So we'll get the full code reference from here. Also, we can get the sysgraph, system graph visualization of the trace. So we can see better what interactions are made. We can see that the Jest testing called my shop service, and then it called the order service, which has a sloth icon on it. The sloth icon means the code. The code of the orders has a code change that was executed. And the service without the sloth icon means we didn't detect any code changes that were executed there. Maybe there aren't any code changes that were scanned there, but for sure nothing was executed. So it's a very, very nice visualization. We also have the system aggregated level graph, which is this one, which aggregates all the traces and tells us all the service level connections between the services. So it's not a visualization of one trace, but a bunch of them. So we'll get a good overview of the dependencies between the services in the system. Yeah. Okay, that's about the sysgraph. Going back to the interactions, we have also integration with Jest, which means that we have a trace per test in Jest. Each test is generating us a trace. We can go to the trace icon and get the full trace starting with the Jest test. And we can see all the drill down how the test operates, what it does, what requests were generated during that test, and a very high-level overview of what happened there. Also, you can see that Jest is separated into two categories. One is changed and the other is unchanged. Changed are tests that were affected by the code changes. We found some code execution through the trace there, and unchanged are tests that if we open them up, we can see that there is no code execution there because there is no code change that was scanned there and executed. So it can tell us whether we have enough tests going through our new code. Okay, so this is about interactions. The last section is the security section, which aggregates us which vulnerabilities were reached during runtime. They are not only scanned, but also reached, meaning these are packages we are using and not only depending on them for, let's say, development or any other use case. But it also means not just reached, but reached by personal code changes. So we can see that on the global view, we have all the CVEs that were traced in the system, but the personal view gives me what CVEs I've triggered as part of my code changes. So I know these lines have actually made an Axios request, which caused calling a function which has a CVE in it. So I should fix that. So we have the code reference, as in every other section, which gives me the exact code selection, the system graph, trace visualization, and tracing the built-in Jaeger. Also, a cool feature that we've added later is once you see the deployed services up top, you can click on each service and you'll get a search for all the traces during the time of the dashboard. That's it. Thank you for listening.